Right. So, see, when you use the word bond pairs and lone pairs, so when we say bond pair, this is for your correction, Muhammad Abdulahad. When you're using the word bond pair, that shows one thing, and that is that two electrons of different atoms, they are bonded together. And when we say lone pair, then the clear meaning of the lone pair is that these two atoms, these two electrons are not bonded. They belong to one atom, but they do not bonded with anything. So we cannot use the word exactly the bond pair over here. Neither we can use the word that bond pair is being transferred, stuff like that. You can't use it. So what we say when we talk about the coordinate covalent bond, that coordinate covalent bond is actually the one when a pair of electron, a lone pair, when some molecules, they do have what? They do have lone pair, or a lone pair of electrons, and they donate it to an atom, and that atom needs to be electron deficient. And that atom needs to be what? That atom needs to be electron deficient. So if an atom, which is maybe XYZ, it has to be electron deficient, which means it has a positive charge, and it receives a pair of electron from an atom, and this atom has this lone pair. Lone pair means this atom has not bonded. The electrons are not bonded to anything. So this is what we call dative bond. We use the terminology dative bond. This is also very common in the exams, and we also use the terminology of coordinate covalent bond. So it's not the bond pair basically, it's the lone pair that has mated by one molecule to another atom, which is electron deficient. The condition over here is the one which is coming in and the one which is receiving this electron pair has to be electron deficient and has to be one which has a space to receive an electron pair coming in. I hope it's clear. I assume that you will have done writing with this. So let's move on to the one very, very, very common example of this. And the common example is this of ammonia. So when you see ammonia, uh, this nitrogen, it forms a covalent bond with these three hydrogens. I repeat, this nitrogen, a nitrogen has how many electrons in its outermost shell? A nitrogen has 5 electrons in its outermost shell. Now, these 3 electrons of nitrogen, these three electrons are bonded with three other hydrogens. However, it has this lone pair, It has this lone pair which has not been attached to anybody. So nitrogen atom has one lone pair of electron to share with the hydrogen atom. Now, this is the hydrogen atom. See, hydrogen atom already has only one electron in its outermost shell. Hydrogen has only one electron. If hydrogen lose that one electron, so it will be left with what? It will be left with no electron in its outermost shell. एक ही electron होता है, वो भी इसने use कर दिया. जब इसने वो भी यूज कर दिया तो इसके पास खाली शेल है. इसके पास एक शेल है. इसका जो फर्स्ट शेल होता है वो के शेल होता है. और जो फर्स्ट शेल होता है उसके अंदर 2 electrons की capacity होती है. So it can receive 2 electrons for sure. So the hydrogen ion required 2 electrons. So what this nitrogen is going to do is this nitrogen will welcome this hydrogen, and this hydrogen will receive what? This hydrogen will going to receive these 2 electrons, that nitrogen. And this NH3 compound will going to be changed as what? This will going to be changed as NH4. From ammonia, this will going to be changed as what? This will going to be changed as ammonium. So this is a very common example of coordinate covalent bond. Are we clear about it? There is another very common example of coordinate covalent bond that is also included in your course as well, and that example is of aluminum chloride. See, a chlorine molecule has how many electrons? A chlorine molecule has 7 electrons in its outermost shell, and aluminium has how many electrons? Aluminium has 3 electrons in its outermost shell. All right, 3 electrons. Let me draw the aluminium over here. So aluminium has 3 electrons in its outermost shell. Okay. So initially what happens is that chlorine share its 3 electrons, 1, 2, and 3 electrons with aluminium. When it shares its 3 electrons with aluminium, the condition will going to be something like this. If we see the molecule aluminium chloride, ये एक एल्यूमिनियम है, इसने एक एल्यूमिनियम ने अपना इलेक्ट्रॉन शेयर किया है with chlorine, and chlorine has its own 6 electrons behind. I don't know what exactly I'm trying to do, but I'm trying to adjust the number of electrons of chlorine. I think, yes. And this will share another like this, and this will share another like this. Okay. Now, this is the structure of what? This is the structure of very famous aluminium chloride, which is AlCl3. No coordinate covalent bond is happening over here. Now, when the coordinate covalent bond will be happening, the coordinate covalent bond will be happening when Al2Cl6 bond will going to be formed. Al2Cl6. Now, how is that possible? See, this aluminium has a capacity. Aluminium has a capacity of what? अगर आप aluminium को देखो सिर्फ और सिर्फ, it has 2 electrons over here. It has 2 electrons over here because इसने क्लोरीन के साथ शेयर किया है, वो शेयर करके एल्यूमिनियम से भी बिलोंग करता है. वो क्लोरीन से भी बिलोंग करता है, वो एल्यूमिनियम से भी बिलोंग करता है. So 2 electrons over here, 2 electrons over here. So this aluminium has 2 plus 2 plus 2, 2, 2, 4, 5, 6 electrons. और हमें ये पता है कि जब भी कोई एटम बॉन्ड बनाता है तो वो 6 इलेक्ट्रॉन्स के लिए बॉन्ड नहीं बनाता. वो कितने इलेक्ट्रॉन्स के लिए बॉन्ड बनाता है? हाउ मेनी इलेक्ट्रॉन्स सपोज्ड टू बी देयर इन एल्यूमिनियम शेल? Yes, that's right. So it has to be 8 electrons. That means this aluminium has a capacity to receive how many electrons? This aluminium has a capacity to receive 2 more electrons for sure. Yeah. So how does that happen? This happens over here. Now what happens is exactly. So for example, this is one aluminium molecule with how many chlorines? It has 3 chlorines over here. And then we have another aluminium. So this chlorine has 7 electrons for sure. One is being shared. So this chlorine will going to give its 2 electrons to this aluminium, and they will form a coordinate covalent bond. And this chlorine will going to give its lone pair or unshared pair of electrons to this aluminium, and here we will have a coordinate covalent bond. Now remember that coordinate covalent bond or dative bond is being represented with an arrow. The one which is donating electron, the one which is donating the electron. So chlorine donates current, the arrow will indicate from chlorine towards aluminium. Here the chlorine is donating electrons, so this will move from chlorine towards aluminium. So that's how it works. I hope this makes sense. See, I draw this structure. What I want you people do is to draw the shell structure with dot and cross model. You do that for me, please? Because the question comes for the surface structure of dot and cross model. Okay, let me tell. Become hybrid. I like it. I like it. See, people, I understand this concept, but see, when you say joining of what, all chemistry is all about the joining of two orbitals together, but the differentiation comes when this joining of two orbitals is happening differently. For example, I'll tell you. So I have orbitals. For example, I have an s orbital, and this s orbital is has a shape of what? Spherical shape. S orbital has a spherical shape. Then I have a p orbital, and this p orbital has which shape? It has a double shape like this. So if it's px, then the shape is going to be this. Then I have a py orbital, and this py orbital will have the shape like this. And then I have pz orbital as well, and this is pz orbital. So they have different shapes. Now, when we say joining of two orbitals, see, let's talk about the two p orbitals joining together. Now, these two orbitals are joining together like this. This is one of the way that the two p orbitals are joining. And then this is one of the way when these two p orbitals are joining. All right. This I'm never satisfied with the all kind of orbital shapes I draw, but it's okay. Now, this is a, can you tell me what do we call or what do we name it in chemistry? This type of joining and this type of joining. There's a specific name on the basis of the way these two orbitals are joining together. So what do we call them? What are the names of what are the names of things? Yeah, excellent. That's right. That's absolutely right. This one is called sigma bonding. And what do we call it? We call it head-to-head overlapping. Mhm. Thank you guys. You have a fair idea. And this one is called as pi orbitals, and this is called side-to-side overlapping. Side-to-side overlapping. Okay, let's then finish it this one because this is also needs to be discussed. Which one is stronger and why? Sigma bond is stronger or pi bond is stronger? Which one is stronger and why? Agreed. Yes, sigma bond is the most strong is more stronger than the pi bond. So what is the reason of sigma bond being stronger? Yes, understand. Very good, Abdullah. Perfect. Yes, that's right. When these side-to-side overlapping is happening in the side-to-side overlapping, these two positive nucleuses are very close together, and this creates what? This creates a lot of force of repulsion, and hence the bond becomes weaker. How, as far as this head-to-head overlapping is concerned, in this, the nucleuses are far away from each other, and less force of repulsion make it more stronger. You are absolutely correct. So what I meant to say over here was that connecting or two orbitals when they are joining together, there are different ways of joining it. But when we specifically talk about hybridization, what do we say? We say that hybridization is that process or hybridization is that phenomena in which two different orbitals of different shape, two different orbitals of different shape and energies joining together and maybe making making orbitals of same shape and energy, making orbitals of same shape and energy. For example, there is one type of hybridization which we say it is sp3 hybridization. Now, what happens in sp3 hybridization? See, carbon has what is the valency of how many? What is the atomic number of carbon? Yes, that's right. So it has six. So what we say is it's 1s2, 2s2, and 2b. 2b what? 2. So this is the second shell. Okay, we are talking about the second shell. In second shell, in s orbital, it has two electrons, and in the p orbital, because p means px, py, and pz. So first, if it has two electrons, first we shall fill px, then we fill py. Now, this particular state is called as what? This is called as ground state. Now, what is the meaning of ground state? Ground state means low energy state. When the orbitals are at low energy. When it moves from the excited state means when a carbon thinks that it needs to bond with someone. So what happens is that from here, this one electron will going to be there in pz. The scenario will be something like this. Now in S, in px, in py, and pz, all of these four atoms have electrons in them. Are you clear till here? Awesome. So I'll pick the same thing from here. I'm picking this excited state and moving forward. So what did we said? We said excited state में क्या होता है? Excited state के अंदर ये होता है कि जो कार्बन की इलेक्ट्रॉनिक कॉन्फ़िगरेशन है वो कुछ ऐसे हो जाती है कि इसके फर्स्ट शेल में तो दो. We will be talking about the second shell only. So second shell में हमने क्या देखा था? Second shell में हमने देखा था कि ये जो S है इससे एक इलेक्ट्रॉन चला गया है किसमें पी जेड के अंदर एक्साइटेड होके. बस एक्साइटेड में यही होता है कि आपकी एनर्जी बहुत ज्यादा हाई हो जाती है और आप अपने आप से बाहर हो जाते. Sorry. So this electron, it moves in this orbital. So this is S, this is Px, this is Py, and this is Pz. So when we say S, S means this is spherical shape. When we say Px, Px means this. When we say Py, Py means this. When we say Pz, Pz are this. These orbitals are not only different from each other in shapes, in their angles, or so many other things. These atoms or these orbitals are also different from each other in energies. This one has a lower energy, this one has the higher energy, this one has the more higher energy, and this one has the highest energy. Now, when these orbitals, they will join together, they will combine together and form four different orbitals. If four orbitals are joining together, then they will also end up on four different orbitals. But they all four different orbitals are going to have same shape, like this. This was S, this was Px, this was Py, this was Pz. But now these four orbitals joined together and ended up on something they will combine together called as sp3, because they are the combination of one S and three P orbitals, sp3, sp3, and sp3. Since one S and three P orbital merge together and form four different orbitals, so this hybridization is known as what? sp3 hybridization, where three different orbitals of different shape and different energies combine together and form same shape and same energy orbitals. Are we clear so far? Now, which element or which compound involves the sp3 hybridization? sp3 hybridization is can be found out where? It can be found out in methane. Now, what is methane? Methane means one carbon. And in this carbon, these four orbitals are like this. One hydrogen attached, one hydrogen attached, one hydrogen attached, one hydrogen attached. It is sp3 and it is combined with the s orbital. This is sp3s, this is sp3s, sp3s, and it's a sigma overlapping, sigma overlapping, sigma and sigma overlapping. Yep, that's right. And it's a tetrahedral structure.